Okay, still under entropy. So the next one is for the AC coefficient, where we will use the RLE encoding. So in each block, 63 will be remaining. So this remaining is the AC coefficient, okay, which contain usually long string of zeros within them. So with this long string zero, okay, long string of zero, RLE is the best technique to be used, where you just represent once, okay, instead of each of the string of zeros. So to exploit this feature, each AC coefficient is encoded in form of a string of pair, okay, with skip and value, where skip is the number of zeros in the run and value is the next non-zero coefficient. Okay, so for example, you already linearize the vector, okay, for the rest of the 63 coefficient. Then you sort, okay, start from 6 until the end. So in RLE, what you will do is to pair the value of skip and value. Skip is the number of zeros. So since there is no zero here, so no zero. So you write it as 0, no zero. Okay, and the next value is 6. Same to here, 07, 03, 03, 03, 02, 02 until 0. So if you see 00 means there is no value next. Okay, 0 means there is no value. So instead of having 63 coefficient, now you only have this. Okay. So example, derive the binary form of the following RLE AC coefficient with this, okay, where the coefficient is this. So how to get this one is by 06, okay, 06, 07, okay, 30, okay, 0, 3, 0, 1, 2, 3, and the next is 0, which is 3. Okay, there is no 0, and the next is 0 at -1, and the rest will be 0. So 0, 0. So how to encode this? Okay, you will encode it as 06, the skip is 0, okay, and the SSS is 3. So means that 6 you will need 3 bits. So the value will be 110. Okay. 7 also you will need 3 bits, but the value of Z7 is 111. 3, okay, you will need 2 bits. So the value of 3 is 11 and -1. Okay, the value is 0. 1 is 1, then you complement, you will get 0. And the last one is 0. So output from the entropy, you will apply both for the DC and AC, you will do the Huffman encoding. So for the DC coefficient, so the default Huffman code for DC is this one. Okay, this one. So how to encode using Huffman? Okay, you will refer to this table. This table is a default. Okay, for example, 12, So the SSS is 4. You need 4 bits. So you will refer 4 as 101. Okay, S4 101. So the different one, number of bit is 1. 1 is 010. 2 is 011. Okay, 0 is 00. Okay, 1 is 011. So the encoded is 1100. So this is the value of 12 after you convert into a binary. 1 is 1, negative 2 is 10, so negative means 01, 09, okay, negative 1 is 0. So the bit stream that you encode to be sent is the combination of Huffman and the encode. Okay, so this will be the encode bit stream to be sent for the DC. Okay, for the AC, you will have the skip and value. Okay, field are treated in a single symbol. Okay, still you will have the default Huffman. Okay, for AC. So the default Huffman for DC is different from the AC. Okay, so for example, this is the AC coefficient. Okay, so you will have skip and SS. Okay, 06. So the skip is 0. The number of bit is 3. So means there will be 0, no 0. Okay, and 6. The number of bit needed is 3. Okay, 0, skip, 7 bit number of bit is 3. So skip is 3 here. Okay, means there are 3 0. 3 number of bit is 2. Okay, so this combination of skip and SS, you will get the Huffman encoded. Okay, for 03 is 100, 03 100, 3 2 is this, 01 is 00, and 00 is 1010. So to encode the AC coefficient, you will have the combination of Huffman code and the run length encoding, run length value. So 6 convert into binary, you will get 110. Okay, so the combination of these two, you will get the bit stream. So this is the AC bit stream. So lastly, you will do the frame building. Okay, so you will form a hierarchical structure. So you will have a few levels. So it start with start of frame, okay, frame header, frame content, and the end of frame. So in frame content, you will divide into a few, okay, block, okay, which is in a second level. Okay, so for this, each scan you will have the segment, header, and segment. So in this segment, then you will have the block. So in this block, you will have the DC, the skip value, okay, skip value until the end of block. So this is how the frame building will be obtained. So once you encode, you will do the decode. So decode, you will inverse the process. It can be progressive mode where DC and low frequency coefficient first, then you do the high frequency coefficient, okay, in zigzag scan mode. Okay, and then you will do the hierarchical mode total, okay, with this. So this is the block diagram of decoder. So there will be a few mode of JPEG. Okay, you will have sequence, progressive, and hierarchical. So this one you can read by yourself. And now we already have JPEG 2000. So the things to address in JPEG, you will use low bit rate, okay, and these are the advantage of the JPEG. So exercise, get the DC, the bit stream of this DC and this AC. So that's all.